Since ice and snow have a low coefficient of friction, the boy's foot easily overcomes the force of static friction. This caused his foot to slide out from underneath him, and there's no longer anything to hold up his center of gravity from the ground. The force of gravity then pulls him down towards the earth, forcing the boy to fall and hit the ground hard.
The boy climbing the driveway distributed his weight among 4 points instead of 2 like we do when we walk. He caused less force to be applied per point when in contact with the ice. This means that the force of static friction was not overcome, so that the boy did not slip.
When I hear a cymbal and a hi-hat with a souped-up tempo, I'm on a roll. It's time to go solo. Rolling in my 5.0 with my rag top down so my hair can blow. The girl is on standby, waiting just to say hi. Did you stop? No, I just drove by, kept on pursuing to the next stop. I bust a left and I'm heading to the next block. The block was dead, yo, so I continue to A1.
The boy who just fell on the ice attempts to make the situation better for the other students by covering the ice with snow. He does this because he knows snow is less slippery than ice. The reason snow is less slippery than ice is that the coefficient of ice is lower than that of snow, causing the force of friction exerted by the ice on a person's foot is less than the force exerted by the snow on the same object. The chemistry behind this is the ice is slippery because of equilibrium. The well-known equilibrium system we know is liquids and gases, but there is a system of equilibrium between solids and liquids as well. There is a thin layer of water sitting on top of the ice, leading to slipperiness. There is much less water present to make the snow slippery because the snow is a whole lot of air and not a lot of actual frozen water molecules. Because there is so much less liquid water present in snow to make it slippery, the coefficient of friction of snow is much higher than ice, causing the force of friction exerted by snow on an object to be greater than ice. This means that walking on snow is much safer than walking on ice. Our good Samaritan boy here had the right idea.
I'm a lyrical poet. Miami's on the scene, just in case you didn't know it.
Because the mascot shoes are meant for walking on pavement, they are smoother than normal shoes. Therefore, the coefficient of friction for the shoes is lower than any other shoe. Meaning, the lack of the force of friction between the already nearly frictionless ice and the smooth soles of his shoes causes the polar bear mascot to fall quite frequently. Ice skates are made up of a boot and a blade. The blade is what you skate on and the part that comes in contact with the ice. As Newton's first law of motion states, an object in motion will remain in motion unless acted upon by an outside force. In ice skating, friction is the outside force that is used to start a stroke. As he angles his foot outward and extends his knee, the inside edge of the blade encounters the ice, and the friction between the ice and the blade creates resistance as the blade scrapes across the ice. Friction enables the edge to grip into the ice. The equal and opposite force of the ice onto the edge acts to propel the skater forward with kinetic energy. The combination of the kinetic energy of motion from the strokes in the ice, and the low amount of friction that exists between the ice and the blade allows the skater to make quick, agile movements like in this Olympic winning performance.
Example of conservation of momentum. The first car did not have enough distance to stop before hitting the second car. The stopping distance of a car is increased on ice because the effective friction on the car is less, so therefore the same action, like stopping the car, takes more time on a low friction surface like ice than one of high friction like pavement. If you notice, the tan car is moving slowly in towards the camera while the dark car is moving more rapidly towards the camera before the collision. After the collision, the velocities of the two cars appear to switch, with the dark car moving slowly while the tan car moves more rapidly. This is described as an inelastic collision since the kinetic energy is not conserved because the cars were slightly deformed in the collision. Momentum is conserved.
Somebody stop her! Somebody stop her! Oh!